Hey everybody, this is Larry. This is basically, what is it? It's July 18th, 2024. Today I am, if you care about my marathon training, I am going on a hopefully 13-mile run, 14-mile run, something like this, depending on how I feel. It's not really it's not a set plan at this point because I think on the books I'm supposed to do like 8 miles. So this is a stretch goal, so that's why it's not set. But it is like 87 degrees right now. It is so hot right now, like about 30 degrees Celsius. And so I don't know. But the reason why I'm doing today, I feel like the last couple of days I have not had the energy, honestly, to do a bonus question, a problem that I haven't done before. So I'm gonna try to do it before my run today, and hopefully this is not a long video. No intro for this video because I feel like I've uh, talked too much about the drama. I mean, like I said, why are we here? What are we doing here? Oh, what the? Why is this a text? What? Oh, bash script. Oh, I didn't. Okay. Uh, I guess that's the shell prompt. Maybe I'll look at shell prompts in the future, but not today. So I had to click on algo, I guess, and I forgot to click on it. All right. Yeah. What am I here for, right? And look, I'm not here for drama. I feel like people are very kind of like given to this emotional and drama, and like for me, I don't. You know, maybe at some point I'll make a when all the facts and stuff and all the dust settles, I'll make a comment. But that's my point, right? Is that like I don't need to be I'm not a detective. I don't it's not what I want to focus on, right? Like is it gonna make me a better engineer? I don't think so, but yeah. Um, Anyway, let's take a look at today's problem. We do have a hard one today. Definitely haven't solved it yet because, well, I mean, I guess if I did, then Leetcode's RNG is wrong. But yeah, you're given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is greater than or equal to k. That has the maximum average value and subarray. Okay, so this is okay. Maximum average value. Oh, I forget that the k part. Okay, so you have to have at least k elements. I mean, I think I say we, and we haven't done it recently. So if you're newer to the channel, then I may be wrong on this. But I feel like we talk about contribution and sliding windows and contributions a lot. And I don't know that this is a sliding windows problem yet, but it is definitely a contribution idea problem. And when I say contributions, I mean that for each element, let's say if this element is the last element in the subarray, what is the contribution to the answer, right? And that's basically the way I would think about it. Um, hmm. Maximum average is such a funky thing, and I think that's I'm trying to figure out how to think about this in a better way. Average is a awkward thing in that it is just like not very monotonic, right? So and like versus I don't know, because I think one idea that I also have, and maybe we will have to go to. Let me look at the constraints real quick. Okay, so n squared is not fast enough, or n times k is not fast enough. Also, just to be clear, right? But what was I going to say? Yeah, I mean, I was also thinking of Cadane's algorithm. I don't like this is a the idea, but it's the maximum sum, and you could do maybe something about the length just as an if statement, because in that case it is monotonic, right? Like if yeah, so I think that is that true? No, I guess maybe that's not. Well, no. It's actually maybe not. No, no. Huh. I'm trying to think about Cadane's algorithm with respect to if we added an extra constraint of length of k, and I think Cadane's algorithm still is true for adding this restriction if if yeah, we just had an if statement. But okay. I mean, they do this thing, and I don't think that's how you would do it anyway, because that's just n times k, as I said. So yeah. So then I want to I think my initial thing is going to lean toward contributions, right? So okay. So what does this mean? What I another way to think about it, at least initially, is that okay. Let's say this is the last element. Then what is the like how far do we get, right? Like if this is the last element, then what is the average of 2 elements, 3 elements, 4 elements, and so forth? Of course, you will also restrict it by k, but yeah. And I guess the first thing I notice is that maybe that's not true. I was going to say that you can do a negative thing, but that's not actually true, right? Because it could all be negative, and then your maximum average is going to be negative. So you still have to kind of consider it. That is funky. Because one idea that you could have is that for each element, maybe binary search to the left. But I don't think, like I said, there's no monotonicity, right? So I don't think that really works. But excuse me. I mean, this is at least initially it seems harder than I would imagine. Yeah, and looking at the bounds, actually, this is interesting. Maybe this gives us a bound for the answer, right? Can that help? The tricky thing is that it's not also exactly k, right? Because if it's exactly k, then it is pretty straightforward. You just have literally a sliding window. But here, okay, let's think about it in terms of average. Maybe that is the trick, right? In a greedy way, let's say we already know the average of this. If we have 50, if 50 is above the average, then we always want to add it, right? And then maybe we want to remove the left side if it's less than the average, because then now, okay, maybe that is the idea then, right? In that way, it's the sliding window. Because here, then, because the idea here is trying to find a thing, and let's say this is your current subarray that you calculating, right? Well, here, and of course you have to keep track of at least k elements. Here, in a greedy way, adding, I don't know what this average is, but it's less than 50, right? So you add the 50, it'll always increase it, right? So it'll give you a better number. And of course, in that way now, maybe, I don't know if this is actually true because I didn't do the actual math for the negatives, but maybe removing one will make it better than you always want to remove it, because this will improve the average. And that means that in the future, if you add more numbers, having this number may improve the average, but it doesn't make it better than your best average, because that's why you remove it, right? So then this may give you a slightly, like let's say this is a negative 20, right? So here, okay, maybe having the 1 will give you a better average, but it does not, this will give you a better average than, so this average, let me just put it more precisely, will be better than this average, but both of these averages will be less than just this one, right? So in that way, you don't have to consider these, because now it is no longer better than the best average. Yeah. Okay. I think that makes sense, and maybe this. I mean, I think like this idea is not super hard to come up with. I guess. Maybe I'm just being a little bit thick and a little bit slow, but I think like the proof is actually like trickier than that. Maybe that's why I'm taking more time. And I think also in a weird way, and this is I've said this about actually the last Q4 in the contest, right? Which is that in a weird way, there there are not that many possible solutions to this, at least without maybe some really high level crazy funky math. So maybe I would have if there are only like 10 possible way of solving this, then like or possible approaches to even be reasonably correct, you could just try all 10 and in your head and then be like, oh, okay, this one's it. Okay, so let's try it. Right. So I think I did a bad job yesterday with respect to explaining my code. I explained my thought process, but I didn't explain the code as I was writing it. So I'm going to try to do a little bit better. My apologies if you have questions about those. But yeah. But basically now we have, this is a way standard. That's the way that I usually write my sliding window. And then here we want the sum or total equals 0. And I guess count is implicit, so we don't need a count. But this is the total. This is the sum inside the window, right? And then now the sum inside the window, we're going to add right. Oh no, what am I doing now? Right, and then yeah, and then while right minus, oh, we also have to keep track of just the best average. So let's just call it, actually it could be negative, right, as I said. So let's just say negative 1e20. Right, and this is a float for that reason. But yeah, while left, so this includes right now, so the number of elements, it's going to be right minus left plus 1, while this is greater than or equal to k, because we shouldn't be removing stuff otherwise. So this is, well, I mean, I did say that in a greedy way, you always want to add this, but we always just add this anyway with a sliding window or with the contribution, because we expect 50 to be the thing. So then we just pop off the thing here. So this is the adding part, and this is the part in which we consider removing, right? So then here and num sub left is if it's less than the current average, and the current average is just, well, I mean, I guess I can write this, but I'll write it out here, right? So average is equal to total over right minus left plus 1. And maybe we could just call this as count, but whatever. So if it's less than average, keeping in mind that with floating points, there are a lot of places to make mistakes. This one is an intentional one, in the sense that if it would, or it's not a mistake, but I just want people to think that when I write this is deliberate. I thought this out about the floating point of it. It's not just like a lazy, it looks lazy, but I want to point it out so that you realize it's just that if these two numbers are very close to each other, like within the margin of error, then it doesn't matter because it doesn't affect the average when you remove it anyway, right? So that's the reason why. Actually, and this is a little bit awkward because then we have to update average, but that's fine. Increment 1, well, okay, num sub left, right? I mean, I did this in the wrong order, but let me type this and then we'll paste it over. And then we have to update average, right? And that should be good. Oh yeah, that should be good. Okay, fine, yeah. So my hesitation was because I was like, oh, but can you get divide by 0 things when you have 0 elements? Because for a lot of sliding window contribution cutoff thing, right? Usually the terminating condition is that it has 0 elements, because by default the while statement will be true with 0 elements. But in this case, this part might not be because of divided by 0. And then I just remembered that, oh, you have this constraint and k is at least 1, so that means that this will terminate before we have a divided by 0 error, right? So okay, yeah, so this increases the average. So this, I mean, in theory, you can do a best as you go max here to kind of get the thing. But as long as this is running, this will keep on improving it anyway. So you can just do it at the end is what my point is. And yeah, you just update the best, and hopefully that's good enough. Yeah. Okay. Ooh. Oh. Huh? Isn't this a comment? Oh, this line. Okay, I mean, we can just delete it. Huh. Why do I have 1567? So that's higher than expected for sure. Maybe it's the K is not. Oh, because, okay, I see. Because here we update before this check. So, okay. So this is where we have the walrus thing, I says. Okay. So as a result, it is an off by 1 error, and it is very lucky sometimes that this happens on examples, because otherwise it's just wrong answer, right? Oh. I guess we have to do it again here anyway for the updated version. Huh. Am I doing this right? Also, we don't use average, so I guess it doesn't really, like, we can just do this. And also, just for slightly more mathematical stability, I guess we can multiply this from both sides like this. Right? Did I mess this up? Why is this 1567? What is that reference to? Left, right, average. Well, I don't know why this is wrong. So let's take a look. 3 and 5. I mean, oh, I'm dumb. I did this loop here. Yeah, I mean, this is just a very beginner mistakes, to be honest. But yeah, if y minus left plus 1 is greater than k. And this is just very easy to fix. Okay. Well, maybe too easy to fix. And also, again, you don't even need average here either. You just do it again. But that doesn't fix it, but it's just an observation. But huh. Left minus right. Am I off by 1? Left, because after this, then left is the next number. So it's not. I think I'm just being dumb. Left is not. Left is the last number. No, left is in it. Yeah. What's going on? Okay, let's take a look again. Zero zero. Okay, that's good. 3 and 5 is. Do I have the answer in this? 12.75. Maybe I'm just wrong, to be honest. Maybe I said all these things and it's wrong. When the length is 4, I guess it's these things should be 12.75. So that means that it should be 0 to 3. This is 0.5. Did I do the signs wrong? Averages. If the average is less than the number on the left, right? So why is it we did it? Oh, wait, what? Huh? Maybe maybe part of my assumption was wrong. Hang on, I think 0 to 4 is 10 to 4. You remove the 1. I think, okay, I spot the edge case. But so the reason why this is wrong is just an off by 1 error. Basically, this is saying that if this is greater than k and the left number is less than total, then we can remove it. But the thing is that now, if this is exactly k elements, it actually removes the number. Remove the number so that it's less than k elements, which we don't want. So we actually want this to be greater than this. Okay, there we go. But as you can see, it's very subtle, but you have to understand the code to debug it. So, you know, hopefully the debugging was helpful too, because I think that's a very, I think like there's an insight to be there, right? Like I think I was thinking roughly the right thing, but I have to be really precise to nail down as to why you just add +1, right? You can't just, I mean, you could, you know, like, you have to understand why to write consistently okay code. And here, I definitely missed that, in that I was taking it to less than k. And another way to, I mean, and ironically, I did make a comment about this, but I could have also done this and just done this, right? Like I made a before we subtract it, I think. Yeah, because this is would be greater than k. But yeah, so I actually, it's funny because I made this comment about how it being not necessary, and then it kind of was, well, I mean, now you don't need it if that. Oh no, oh no, my answer is not optimal enough, huh? Man. Okay, well, I mean, at least we you know, we're learning together. I should just like not delete this code. Keep on writing it. Huh? What is 6? What is 7? You have 7 elements. Man, the reason why I'm like rushing a little bit, to be honest, is because I need to use the restroom. So, alright, I'm gonna use the bathroom. BRB. Sorry, friends, for the interruption, but I want to keep these things live, as I always say, so I don't want you to think whatever. But sorry, friends. Like I said, I wanted to. Yeah, all my videos are mostly live. Sometimes I edit it out when I, you know, expose a password or something like this. But otherwise, like, everything is live, so that's why I did this way. And also, you know, right, for those at home, you can fast forward, so that should be fine. But okay, let's take a look into why. Oh, because this is exactly the same, so it doesn't try, because the 7 shields the 4 being removal. I guess if it doesn't, I guess I was wrong about it. Doesn't matter. Yeah, and then oh well, I mean, this part is different. Oh yeah. How? How is this? I mean, I guess so, but I guess for k is equal to 1, it actually eliminates it so that it's still elements. But okay, so why is this not right anymore? So okay, so you have okay, you have this thing. What was the case again? This is just hard to Huh, maybe I'm wrong on this problem. I thought that would be right, but so okay, so I'm definitely wrong on this. I guess this is the case, right? Because the idea here is that after you remove this, and then you could remove this to improve it, but you would never remove the 7 because the average is 6.5 and 7, so you have to remove 2 elements to improve the average or something, or maybe at least 2, maybe more than that. It seems like at least 3 even, right? Maybe at least 4, right? To improve the average. Huh. So okay, so definitely that does not mean, that means that this is not sliding window, and this test case actually is is specifically for what I wrote. So okay, so I'm really wrong on this one. So that's why I had a feeling that this was wrong. That's why I kind of used the bathroom, because I know that this is gonna be long, and I couldn't hold on. Sorry, my bad. Hope you fast forward. But okay, so then let's try again. So okay, so it is not sliding window, or at least not the way that I did it. So I mean, this is a good test case, so I'm trying to. Oops. Presumably it is like 2, 3, 4, 5, 6, 7. I guess 7 would be this. I mean, is it just binary search? Maybe? I don't know. Okay, actually I want to step back for a second. I think one thing that we said earlier is that no, that's not true. I thought I had a statement, but that's not true. All right, okay. Let's. I think the hardest part about a problem is sometimes resetting. So let's reset this, and let's restart thinking as much as we can. Can I do like? Can I do? I'm just thinking about like just even various ideas. So I mean, this is one of the 10 approaches that like I said, there are really not that many possible ways of doing this unless it requires crazy math. Another thing that I was thinking of is just like this idea of like greedy breadth first search things. Or not even that, but kind of, but like with union find, some sort of thing where like you start off and then just kind of branch out. Would that even make sense? Because basically in a no, I mean maybe, but not in a easy way. Because the thing is that, like, for example, you can say, you know, maybe you have like let's say k is equal to 4. You have, I don't know, right? And then you have like 100 and then negative 50. In a greedy way, would never go to the thing. You know, this average, like if you have this, what is this average? 1050 over 3, so like 300 and something, right? But here, like even just going here for k is equal to 3, or k is equal to 4, whatever, like in a greedy kind of way, you would probably just go this way. Like if you're trying to merge components, and that would be lower than your average of just this, right? I mean, yeah, okay, that's actually not k is equal to 4, but you can add another element or something. So, trying to think about how to exploit the fact that there's k. This is the hard part. Definitely harder than I anticipate. Can I use this? The width of the average is just so hard for me to handle. I really thought though. Because here, well, here would include all this stuff, but it is more precise to say this is, because this is 5.5, so this would be actually thing, but we will now remain with 7. Still hanging on some ideas of binary search, but I don't know how to do it necessarily. Mostly because of the negative numbers. Well, is that true though? Huh. Maybe I could, if I could get rid of the negative numbers. I mean, I could actually I can get rid of the negative numbers, right? But because it just raises the average by the same amount. What does that mean? Does that now allow me to binary search? Because you still need the average. That's the problem. That's the hard part, right? Like you can't just. Like the length matters, so it's still not a monotonically something function. But that is an interesting idea. But you have to search for k, n, and n, so it's a little bit tricky. I don't know. And also, like for this one, right? I think the thing that I was saying, or I was thinking, is that maybe k has to, maybe k doesn't, or k matters. But here, even if k is equal to 2, in a greedy way, you would just do this. Yeah, this is your max length 2, but clearly length 3 and even length 4 is much better, right? And it has nothing to do with the negative because we can renormalize it. I mean, I think we can maybe think of it as a stack problem, maybe, and then merge them that way. For example, here, we have now. Let's say we have this as the possible answer. We have one. We put it on the stack. We put it on the stack. We put it on the stack, and only when it's but putting on the stack is fine. But then how do you say like, hey, this is now a new better answer? For example, if you have like this, then here you put this on the stack, this on the stack, but then here maybe just at a certain point. Well, I don't know how to do this one, huh? What is it about average that I can exploit? We can, I mean, k times n in any way is not possible. This is the only. The answer has to be within these, but I don't know that that helps. Or at least not in a way that I can do it without n squared. Because you can't binary search on it, binary search on the sum. But then you have like two dimensions. One is k, one is the length. No, the other way around. Or one is the length, one is the sum. And then maximize all of it. Can we DP? Maybe, no. That's still k times n, even if we keep merging in a good way. Okay, we established that the negatives don't matter. I mean, it now creates a monotonically increasing part on the sum, but it still doesn't on the average. Right, let's think about contains algorithm, right? Am I close on the sliding window? I don't know. Is there another way? Oh, I'm so tired. I'm still yawning. Maybe I need a nap. I will not record that live over it. Yeah, I mean this answer is definitely 3k. So that means that we can't really well, I mean, okay. Let's think about this, right? I mean, I guess we can do ternary search on k. because the idea being that the more elements you add, the answer for that is going to be the more elements that you add, it'll probably go up and then to a point and then drop, right? Is that true? I don't know. All right, I'm going to it's more of a gut thing. I think that sounds reasonable, but I can't. I don't want to spend too much time over proving it just because I'm not that confident about it. But I think you could do a ternary search on K. The idea being that, okay, let's say that you have an answer for a certain K, adding an element would, is that monotonic in the error? No, I don't think that's right, because here you can maybe say something like this, then 2 elements, 3 elements is going to go down, and then it goes up, and then you can maybe even say another. So then now, so the peak element is going to be 4 elements, but but this is down, down, up, and then down, and but then it can also go back up to here, right? And the reason why it goes this is because then now 3 is I don't know, but I'm not convinced enough. Like, I kind of want to do it just because I have any ideas. I mean, let's do it just because I don't have any idea, and then we'll get a wrong answer, and then we'll kind of debug that answer. But I don't know. Thanks. Okay, if f1's better, then we divide, then y is equal to 2. Oops. And then this is how I write my ternary search. This is for a given K, and this is just a regular sliding window thing, right? So for let's use, well, I don't even need that technically, because this is exactly length X. So then now total oops, what the, oh, if y minus the can I have a, oh. I don't know. I don't think this is right, like I said, but we can at least give it a spin. What am I getting wrong? 19. What? Not. Oh, it's a float. What's a float? Oh, this is a float because I am silly. Because this is on K, not the other thing. Okay. I mean, at least now we know it's wrong. Hmm. I don't have any idea though. Also, honestly, this is not. Okay. Well, let's try again. Oh. Okay. That okay. So it is. I just had no confidence about it. As you can see, let's give it a spin. We'll probably get a wrong answer, but I'm curious what the wrong answer would be. Okay. Like I was hoping that that was the case before, so then we don't get a wrong answer. But I mean, it's not a contest, so it doesn't matter as much. But yeah, so here we can see that yeah, here we can maybe apply. And yeah, as you can see, this goes some. Did I mess this up? Is the curve wrong? Because 3 is the minimal. So, oh, maybe I got the curve wrong. No, I mean, this goes up. Oh, no, this is a different problem. So, okay. So this goes down as you add more elements. Yeah, actually, maybe I just got it wrong. This goes down as you, and I just got lucky on the test cases. But this goes down. I was actually thinking about the other curve. I just not thinking about autopilot. Okay, so that means that if you have a curve like this, if mid 1 is greater than mid 2, then wait a second. This should be n-1, but for inclusion. But so now here we go. Let's do this for some reason. Was that wasn't right before, right? Like, did I mess it up? Oh, I do have a right +1 here. Well, yeah, okay. Yeah, I guess it's not strict, but okay, fine. What is going on here? It looks okay. So 3 and a 5, because we're trying to get. Okay, so then. I guess conceptually it should. Yeah, okay, fine. So, but this is. I don't know if this is. Because basically we're doing the discrete numbers, and this collapsed before we kind of got behind it. Usually I write it a little bit differently, but this one is a very awkward one because our bound starts at k instead of 0. I think that's the biggest difference. But yeah, so maybe we do something like this. Well. Yeah, but I mean that still fits the curve. It's just that I think my constants were a little bit awkward because it chops off before. This is a ternary search thing, but I still expect this to be wrong. But at least we'll get a better wrong answer than that one. And now this is a too good of a wrong answer, unfortunately. So okay, but it gives us something to explore. So I don't know. Okay, so the answer is 517, right? Yeah. Okay. There we go. There's a proof. I wasn't able to find one, but on my thing, and that's the one that I want to figure out. Right? And what I mean is that it goes down, up, down, up. So then it's not monotonically at all. So you never. So there's no ternary search solution for this. I didn't really expect it, but I was hoping to find a case that will give me more understanding about it. That's why I did it this way, um, which I guess I did now. Uh, okay, at least I still know how to do ternary search, kind of. Okay. But it does converge. Oh, but this is all the K. I meant to do it from K, I suppose. So yeah, as I said, it goes up and then down, and so that's why you never have a good enough answer for this this way. Man, this is taking me an hour. I was hoping this today would be a quick one and done, but okay, fine. Yeah, it's gonna be this, but there's a lot of elements actually. Alright, either way, hmm. Yeah, I mean now we still have we're figuring out how to figure it out. Okay, so it's not monotonic at all. Like I'm trying to treat it as if like if I was a contest, what can I do with? Am I missing some? I feel like I'm missing some one like key thing today. But also by the same token, that yeah, I mean, so it's not. Man, is it dynamic programming? I hope this isn't one of those problems where like, yeah, it's input dependent. My eyes are so tired. Hmm. Yeah. Sorry if this is a boring video. I have no idea. Okay, so the function, so you can definitely not binary search on K regardless, or I mean, because we tried ternary search, it doesn't work. When you do it with the answer, how would you even do it with the answer? Because you can't even just like add and remove stuff as whatever in a greedy way, because if you did that, then that would just be the answer, and that's our first submission. Because to get you can't even binary search into the past, because it's not even like the past is not monotonically increasing, right? I don't know how to do this. Like maybe we can exploit something about this. Like in a DP kind of way. But K is not in any way greediable, it seems like. I think I should be able to do this. Negatives almost no matter for the average. And I do one like 13 miles later. Not gonna lie, I need to use the bathroom again at some point. My stomach, I don't know. I ate some really weird seafood sometimes, but contains. I think we can use some contains. How do we use contains? Then, okay. Alright. Alright. I mean, you're here if you're watching this and you've been watching for an hour. My apologies. Feel free to fast forward a little bit. I thought I was gonna just in and out, but I don't know. I used the restroom again, so be on me. Sorry, friends. Just one of those days. I don't know. Alright, friends. We're now in. We have about a line or two of code. They're not even real lines of code. But I think thinking about contains makes me think about. Okay, so I think I have an idea. The idea here is that we can binary search for the answer because then now we're just trying to find using Cadane's algorithm kind of, but instead of the maximum we find the longest where it is above the where it is non-negative, right? So maybe we can do something like this where left is equal to the min element, right is equal to max element, right? And then this is binary search, and this is continuous binary search, right? So mid is equal to left. And then now if good of mid, if this is good, then we try a bigger number, right? So then left is equal to mid. And this is, like I said, continuous. So then now we have a target, right? This is there an subarray? I don't know if this is true though. Like how is of at least length k with this average? Like, yeah, I guess, yeah, okay, fine. And then basically the idea here is that, okay, we have the sum, we have for and count maybe, right? And then for x in nums we go total, we add nums sub, oh no, not nums, x minus target, right? And if total is less than 0, then total is equal to 0, count is equal to 0, because then well, maybe just same as whatever, right? Same as the which contains algorithm. And then else, well, we just increment by 1 to count. If count is greater than equal to k, then we return true, otherwise we return false. Because then the idea here is that we're just trying to make sure that total is greater than 0, then the average should be good, and we don't care about the length. Do I have any prints in? Why is it so slow? Oh, this is dumb. Because this is, I knew I forgot something, but yeah. It doesn't have anything. I usually write 200 out of habit, but because it doesn't really matter in terms of yeah, but this is quite a little bit wrong though. At least even this one, which is unfortunate. Because the idea is that, you know, why is this for 0.5? This contains algorithm, but then here, I guess this goes to the negative. Yes, this goes to the negative, so then I start over. So maybe I have to think about it in a different way. Okay, yeah, so this is not right either, I guess. Because this starting over may not make sense. Okay, so let's say it dips into the negative. How can we change that? Can I use my original idea? Like this one? Of sliding windows? Because then now, As long as it's greater than 0, it doesn't matter, right? Well, let's give it a try. I don't know anymore. Right, okay. And we want total we added by num Subarray minus target. Right. So then now, same idea. I'm just gonna is less than 0. Yeah, so we want to remove stuff from the left, that is. Yeah, and total is less than 0. Okay, yeah, because you don't have to remove stuff if it's greater than 0, right? So then now is if right minus left plus 1 is greater than 0, okay, and total is greater than 0, or equal to 0, I suppose. Maybe rounding errors, but we'll see. Maybe something like that. How do you have 14.5? That's a very concerning error. The other ones are at least reasonable, even if wrong. But how do you have 14.5? Oh, I guess I should include target. 14.5. What is the input again? Okay, so negative, really big negative. And then when you add 50, what is the sum of this? Oh, this is left, Larry. What are you doing? Silly mistake. But, I mean, it's still, oh, I mean, it's right for that case. Not for the other ones, though. I mean, that's some progress, I guess. Oh, yeah, because of the loops. Doing is fine. And then now with binary searches. Because so we're still stuck in a local minimal thing. So maybe this isn't quite right. That's what I was worried about, but I just didn't want to play with some ideas. What is the first element in this one? 64? So if it returns true, it tries to bigger. Let's see. This actually gives us false, which is actually not great. So definitely we need to, if this works, we need to do a little bit better. Is there another way to do another binary search? Okay, let's say now we have this 0 thing, and we have a prefix sum of all the things that we looked at. Right? Okay, let's say we do prefix sum. What would that look like? Maybe the 0-ness now gets us something, right? Because now okay, I think I got it. I mean, I guess it's just too. That's a hard problem, though. This is kind of unexpected, to be honest. But okay, let's give it a spin, right? Okay. So let's say we want k, then that means that, okay, let's say this is the current prefix sum, right? Let's not worry about this for now. Okay. This is the current prefix sum. And okay, let's actually create a prefix sum. Right, so then now okay, right, so that's the prefix sum. We basically just want to know, so then, okay, so then the current prefix sum is, right, of course, the new one. So that means that in the past, if we exist any number of current or smaller than that, then we're good, right? So that means that, let's say we have a sorted list. I'm more confident about this one now, actually, but it's still just awkward. Okay, right? And then now, if, okay, if sl.binary search bisect left of current, if it is greater than 0, that means that one number exists that is less than 0. Then we return true. Otherwise, then yeah, then nothing happens and we return false. We have to insert into binary the sorted list, and it is just if right minus k is greater than or equal to 0, then we have to face that in. Maybe I'm off by 1, to be honest, but let's see. Okay, well, that's no Gucci. This number's, I mean, it's still not right though, so there's something weird about this, but at least it runs. I am confident, or more confident about this. I don't know if it's just an off by 1 thing, but yeah, target current SL. Okay, let's print some stuff out. So 0. And the sum is 7. this 0 may be an issue. Is it? Yeah, but that means that current is above, right? So I don't know if that is an issue. So the target is 8, so we subtract 8 from everything. We have a 7 is the current. Let's add the right index. So we have at 5. I mean, there's no reason why that's wrong. But I think I need the other thing too. Okay, so we have a huge number, so this is all negative. So the list is going to be, am I doing the signs wrong? The sorted list with binary search on negative. Okay, so 50, we should definitely do one with 1. Right, so I think maybe I am off by 1 here. Still wrong answer though, but it's a little bit closer. Oh, maybe the right answer for this one, but definitely not the right answer for Q1. I feel like this is the right idea though, so, or at least, I mean, maybe it's too slow, but at least it should be. This makes sense. So what am I doing wrong? Right is 4. The target is 8. And let's actually also return the prefix here. And also here, let's do target. So for target 15, I'm still off by 1, I think, because the sorted list should have more than 2 elements, because this 3 should consider the negative, should have 3 elements, right? So, okay. I mean, it may time out, but I think the idea is a little bit better. And we could change some stuff, maybe. Okay. I mean, maybe we're on the right track. Can we optimize this? Let's think about it. How long does this take? Oh, I mean, this is slow, but it's not that slow. I mean, we can definitely cut this down. I always just write some big numbers here anyway. So, and this is pretty straightforward optimization. Well, let's just submit it. Yeah, it's a little bit YOLO, and we can actually probably shrink this a little bit more, but yeah, okay, okay. I mean, we definitely can a little bit, but at least it's right. This is a hard problem. Like, can I have done this without sorted list? Yes. Well, yeah. Yes, because all you care about is the smallest number, because you're looking for the numbers that are smaller than the target. So here we can actually replace this with a min. Min is equal to say infinity to begin with, and then then here min is equal to oops, min is equal to min, right? Yeah, and then now if current is greater than min, or maybe even equal to, really, then yeah, okay. We don't need a sorted list anymore. It's here, okay. Should be right. Yeah, okay. Now I'm a little. It's still not great, but at least like this is just binary search, and I'm happy about this. I mean, like maybe you could be a little bit tighter if you just kind of write this or something like that. I don't know that that matters that much in my mind. Like, I mean, math is in one time, but I don't care that much. Um, and maybe you could do the math to be more precise because there is just, what's it, 10 to the fourth. The and your error is 10 to negative 5, so you have 10 to the 9, which is about the, I mean, this is about right in terms of tolerance. But yeah, this is a very hard one for me. I mean, as you can see, I did a lot of things. The key thing here is just the key observation for this problem is that there's a total and there's an average, and that's two things, and try to remove it such that you only care about one thing. And here, that's how we did it. By using a target, we got rid of not the yeah, we got rid of the thinking about the average in a moving kind of way, and just thinking about positive and negative and prefix sum. I think that's the struggle I had with. I mean, I kept saying binary search. I didn't mean actually initially mean it in this way. When I said binary search, I meant like given the index, binary search how far to go to the left. And for that, I actually did think about prefix sum for a while, but but um, but I was able to get it because the average changes, right, with the total and the thing. But then as soon as I was able to kind of come up with this, and much later, like I think I had a lot of the pieces together in a way, but or not together. I just had a lot of pieces, and it was tough kind of putting them together after a while. As you saw, I was just trying to do it, and the way that I wrote this is just like a delayed, and you could write it with a deck, but a delayed event type thing. But then I was like, oh wait, no, you don't need the binaries. I mean, but that by then it was just an optimization, right? So, um, hmm. Yeah. So what's the complexity here? This is, O of D, where's the number of digits of precision, maybe. So I just did 30. And this is obviously O of n time of n space. So yeah, I am. I mean, I don't want. I mean, I think the analysis is fine, but I do want to go over, just like look over the solution, right? Iterative. I mean, obviously, k times n is going to be 2, or even n squared is going to be 2. So, binary search, is that the thing? What is the binary search? Yeah, I mean, I mentioned that a few times. I mean, I obviously brought up binary search a couple of times early in the beginning, but yeah. I mean, yeah, but the rest is tricky. Okay, fine. Oh, huh. I mean, I didn't think of it quite this way, but I guess that makes sense. Maybe I should have written. I mean, this is way easier to figure out when you write it out, but maybe I should have written it out. Maybe that would have been a little bit better. But yeah, minimum cumulative sum. That's basically what I. But of course, that's after I did a second binary search. Yeah. Okay. So I mean, what they're saying is that basically what we have, right? Uh, yeah. I mean, you write the error, but it doesn't. This is a very weird way, but or at least weird to me. If that is new. Okay. I mean, it's fine. This one is very hard. Uh, okay. I mean, honestly, oh, what the convex hull window? Say what? Uh, okay. I mean, I mean, I don't know. If you need a paper to, I don't know. I mean, I'm sure it's right. I don't know if it's worth for me to learn it. Man, this is pretty tricky. Pretty hard problem. Because I think there's just like 3-4 steps you have to do. A very good problem. I'm not trying to like diss it. I'm just trying to, but yeah. But I'm just trying to think. I mean, I think right now I'm just trying to think about. Right now I'm just trying to think about how I could have done better. Because this is an hour and a half video. Yeah, I mean, I think honestly also a good amount of it is that I did underestimate this problem. I thought it was an early problem, so it can't be that hard. And I just thought that would be one thing. And I did do the greedy, I did the ternary search. I thought about this idea for a while, but I just couldn't put it together. It just didn't make sense to me to binary search for the average, or at least I didn't know how to handle it until I thought about doing this thing where we treat everything as above or below the zero line, because then now that's how you get rid of needing to care about the number of elements in a way. I mean, you still do, but now the number of elements is not in the calculation anymore because the average is just either it's positive or negative, right? And I think that's the biggest part, this part. And then everything else just kind of fell in, right? Like now that we have, because then it becomes a searching problem, right? And that's why I kind of did the sorted list, because I was just trying to find the number that's smaller than it, and then the optimization was after it already got accepted anyway, which is that I was like, oh wait, in that case you always in a greedy way just find the smallest number, right? So yeah, pretty tricky. I don't know. Let me know in the comments whether you think I could have done a little bit. I mean, I probably could have done better, but where I can be better. That's all I have for this one. Let me know what you think. I'm gonna go take a nap and go for my run. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.